When we talk about combustion, okay, we're looking at the fact that oxygen is involved in a reaction and it causes, okay, a large amount of energy to be released. Oftentimes, combustion is linked to something called the triangle of fire, okay? Not the ring of fire, but the triangle of fire. So if we have a triangle here, okay, and we've got beautiful, lovely fire on the inside here, there we go. Okay, so we've got our little, okay, here's my flame. In order to get this triangle of fire, in order to get combustion, you need to have 3 components in a combustion reaction that are always present. Okay? If 3 of them are present, then there's the opportunity for a combustion, i.e. fire, to occur. So when firefighters are fighting fires, they usually try to eliminate one of these 3 items in the triangle of fire to put said fire out or to not cause a fire. Okay? So one of the first things you need is something called an oxidizing, oxidizing agent. So basically, this means oxygen, O2. If oxygen is not present, a fire will not burn. Okay, I have candles at home that have lids to them. And sometimes I'll light them if I've been cooking something that has a strong smell. If I want to put the candle out, usually what I tend to do is I put the lid on top of it. And at some point, very quickly after, the flame actually winks out. And that's because I've cut off the oxygen supply. The flame has burnt through all of the oxygen. So it will not actually burn anymore. How many of you have a fire extinguisher in your kitchen? Okay, you should. I have a tiny little guy that I keep in the kitchen, and it's a special fire extinguisher just for kitchens. Because what is the most common type of fire in a kitchen? An oil fire on the stove. Okay, when you're using oil to fry something or whatever, and you leave it on the burner for too long, it can catch fire. And have you ever tried to mix oil and water? They do not work. Okay, water does not mix with oil. So what they often tell you to do in that kind of fire is to try and put the lid back on the pan. Okay, because you're snuffing out the oxygen. But if you use a fire extinguisher, that fire extinguisher will not actually spray out water. It will spray out this foamy kind of chalk substance that will cover. It's like a white substance. Okay, it almost looks like shaving cream, but it's not. And what it'll do is it'll cover the fire and it'll make a protectant barrier between the flame and the oxygen outside in the air surrounding. So will the fire be able to burn? It will not, because the oxidizing agent will be removed. Okay? The second thing that a fire always needs is fuel. You cannot have a fire without something to burn. Okay? So fuel, a lot of times we think of fuel as gasoline and oils and things like that. But in a forest fire, what is the fuel?
Trees.
The trees. Okay, the wood. If you have a fireplace at home, to keep the fire, it keeps the fire burning. Okay, newspaper is a fuel, absolutely. When there's forest fires outside, okay, like those big forest fires that have been burning in California, okay, when those fires, what the firemen will tend to do is, yes, some of the firemen will be trying to douse the flames with water, but others will actually be ahead of the fire, and they will be cutting down trees and digging these big ditches so that the fire, okay, when we talk about actual combustion, we're talking about these 3 substances. So we need fuel. Fire will not burn, or combustion will not occur without any type of fuel. You will not make energy without consuming fuel or food, right? You cannot expect to be a high-performing athlete if you do not constantly refuel your system. Same sort of deal. Ignition temperature is the temperature at which we need combustion to actually start. Depending on the situation, the combustion or the ignition temperature might be very high or it might be a lot lower. It's a lot lower when it's very dry out. Okay, fires can start much more easily. Okay, or easier, whatever you want to call it. And then finally, we talk about the idea of the oxidizing agent, which is basically air. If fire does not have air, if you do not have air, you cannot cellular respirate. Okay, the cellular respiration formula, C6H12O6 plus O2 yields carbon dioxide plus water plus energy. You don't have that oxygen there, you're not breaking apart the sugar. Okay? So cellular respiration is another example of combustion. It's like an organic form of combustion. Okay? Now, there are 3 types of combustion. The first one is the one that we are kind of used to and we associate fire with, and that is rapid combustion. Okay, rapid combustion happens very quickly. Okay, it gives off a lot of energy within a short period of time, and it's usually an example of fire. Okay, fire is usually the perfect example of something that combusts rapidly. The complete opposite of that is slow combustion. So this could be fire. Slow combustion is something like rust forming on iron. Fe is iron. And what I mean by that is rust takes a very long time to accumulate. It's a very slow reaction where the metal is interacting with the oxygen and it's causing a chemical reaction that breaks apart the iron. Okay? That is a slow form of chemical combustion, and it takes a very, very long period of time. It is not quick. And then that last type is called spontaneous. Now, spontaneous combustion, okay, is a rapid combustion, but it's one where the actual ignition temperature is reached without outside help. Okay, a really good example of that is when it's super, super hot outside, okay, and dry in the summer. Fire, sometimes when you go, some of you go to camp, right, for the summer, and the fire warnings might be at high, and you may not even be allowed to have a campfire because it's so dry out. And that a hot sunny day, sometimes the sun can be enough to actually ignite really dry wood. Okay, no reflection from broken bottles, no matches, no cigarettes, no lightning. It's just that the ground is so dry and hot that fire can start like that. Okay, so when the ignition temperature is reached without any outside help, we call that spontaneous combustion.
Is that like forest fires and stuff?
Forest fires that are started without human negligence or lightning, yes. They're just started because it's super, super dry and hot.
Just
Naturally starting, okay? That is spontaneous. So when we just talked about the fact that cellular respiration is an example of combustion. It's a human form of combustion. You cannot create any energy without consuming food, your fuel that you break down. Okay, so if we remember this, that should be a C6H12O6 plus 6O2 yields 6CO2 plus 6H2O. That's going to give us energy. This is cellular respiration. Okay? Now look at this. What do you think is the fuel in this reaction? No, oxygen is not a fuel. What is this first molecule? What does this stand for? What is C6H12O6? It's also known as glucose, right? What is glucose? It is a sugar. So here is your fuel, okay? Sugar is your fuel. What is your oxidizing agent here? The oxygen you inhale, right? Here's your oxidizing agent. Now, your reaction, your ignition temperature is fairly low in the body. Your ignition temperature ends up being about 37 degrees Celsius because this is happening inside your body. Okay? So all three of these important items in the triangle of fire are present here. Now, what is the opposite of combustion? Incombustion? No, but that's a really, really good try. Okay, so when we combust, we break down. Okay, so when we break down, we call that an exothermic reaction. Now, an exo means leaving. Thermic means thermal energy. So when you break down energy through cellular respiration, you release energy, right? You release body heat. You use that energy for whatever. It gets released and transformed into something else. The opposite of this is photosynthesis, because photosynthesis takes carbon dioxide, it takes water from the soil, and it uses sunlight energy to create sugar, C6H12O6, plus oxygen that it does not need. So when you make something, the opposite in the science world of exo, leaving, is endo, entering. Right? You're creating potential energy here and fuel. So this is an endothermic reaction. You're making energy. Does that make sense? Okay? So when we talk about the forms of combustion, one of the things you could see is you could see a bunch of examples or situations, and it could ask you in that situation, which of the three items in the triangle of fire is being addressed here? Okay? Does that make sense? There was a car on fire in a parking lot not far from where I live. And one of the first things that the firemen did was they doused the cars right next to that car on fire with water. Why do you think they did that? They lowered the ignition temperature here. Okay, they made it so that it would take so much more energy to try and set those cars on fire. They do that with houses. Firemen will actually spray neighboring houses and buildings of a fire to make sure the fire doesn't spread or to slow its spread. Because by adding water there, you're making that ignition temperature unattainable. It will not light at that low of energy. Okay?